The other thing that we routinely use in chemistry that you don't use nearly as often in math class is scientific notation. Scientific notation is basically used to take large numbers or small numbers and just make them manageable. Honestly, it actually helps us perform complicated calculations in our head more easily. But what are some examples of what it looks like? Well, when we write out the speed of light, instead of writing it as 300 million meters per second, we could write it as 3 times 10 to the 8 meters per second. Or the mass of the electron, which is a very tiny decimal with all these zeros in it, we could write it out as 9.1 times 10 to the minus 31 kilograms. Now, scientific notation has a couple parts to it. This Avogadro's number is a familiar measurement from chem. It's made up of the coefficient. The coefficient is the actual measurement. Then we have the base and the exponent, which collectively are called the order of magnitude. And these tell us how large or how small the measurement actually is. And last, there has to be some sort of unit of measure telling me what exactly it is we're measuring. All right, when we are multiplying or dividing numbers with scientific notation, keep it simple. You start by multiplying or dividing the coefficients, that's this part, and then you follow it up with times 10, and when you are multiplying these, it means you add together the exponents. 3 plus 4 is 7. When I multiply these two digits together, I get 15.6. The last thing we do is make this look more like standard notation or standard scientific notation, which means we move the decimal point one place to the left. And when it goes one place to the left, the exponent goes up by 1. So the final answer for this would become 1.56 times 10 to the 8 meters. Now, it's multiplication, so it's actually meters times meters, and I add a square to that. Now for this one, if we take these numbers and divide them, you get 5.0 times 10. Now when we divide, our operation is to subtract exponents. 7 minus 4 is 3. This is 5.0 times 10 to the third liters per second, which would be like a flow rate. All right, adding or subtracting in scientific notation is a little bit more complicated. Luckily, in chemistry, it seems like we are always multiplying and dividing. We're not as often adding and subtracting. But when we're adding and subtracting, not only do you need to make sure the units match, you also have to get the order of magnitude to match. So if we're adding this, 3.41 times 10 to the 6th meters and 6.25 times 10 to the 4th meters, our units match. Our orders of magnitude don't. You have a choice. You could either change this one to 10 to the 4th or change this one to 10 to the 6th. To change this one to 10 to the 4th, we would have to move the decimal point to the right to get this number to drop. Instead, I choose to take this number and change it to 10 to the 6th. What we do for that is we move the decimal point 2 to the left. When you move it to the left, this number goes up. When you move it to the right, the number goes down. So if I move this 2 to the left, it becomes 0.0625 times 10 to the 6th meters. So now when we add these together, we get 3.4725 times 10 to the 6th meters. Now, we still use the rule of adding and subtracting where we tally up the decimal places and use the one with the fewest decimal places. So we're going to go with only 2 decimal places, and this would become 3.47 times 10 to the 6th meters, and we're finished.